Welcome back to another lesson with Ming. Today we talk about scatter plot. Here the question is, how do we represent two sets of continuous data? Here I have a selection of data about cigarette consumption for all the states in USA. Now we look at how we can represent this set of data on XY plane. X here is the cigarette smoke per capita in hundreds, and Y here is the lung cancer death per 100,000 people. Make sure you label the axis properly as it is. So for example, the data point here, X is 40.46, so you measure 40 and you read 40.46 going up, and then Y is 27.27, so this is the point for here. And the next one, we have 33.6, X is 33.6, and then Y here is 24.55, so it's this particular point. And you repeat this process for all the data set to obtain this particular plot. This particular plot is called the scatter plot. It's called scatter plot because the data seems to be scattered in this XY plane. Before we go on further, let's look at these two sets of data. If you have a scatter plot that look like this, where as the X increases, Y actually decreases, then we say that X and Y are negatively associated. And we also call this trend negative. The trend here is negative. In this particular set of data, as X increases over here, Y also increases. So X and Y are positively associated, or the trend is positive. The strength of a linear relationship is called the correlation coefficient and is denoted by the symbol R. So here, the emphasis here is linear relationship. So for this particular set, you can draw a straight line across it. So, and over here, the trend is, you can also draw a straight line, but not as strong. And you can see that the data are not as tightly or as close to the line as possible. Now you may want to pause the video and attempt this question number 2 by yourself before pressing play. Alright, welcome back. Let's check our answer. I'll start with D. For this particular set of data, because the data seems to be randomly scattered, we say this is no association. And for this one, which is very tightly linked to a line, this we say is perfect positive association. Perfect positive association. And the next one is this. This is a weak positive association, whereas the last one is strong positive association. So when the data are distributed as closer to being aligned, then we say the association is stronger. Having said so, not all association between two sets of data like radioactivity and time are linear. Alright, before we go on further, you may again want to pause the video and then attempt this question to check out what kind of trend line are these, and when you're ready, press play again. Okay, welcome back. Diagram number 3, here the trend line look like this. This is a exponential decay pattern. Diagram 4, this is a level of pollution and economic development. And here the trend look like this, which could be a quadratic function. And for all these 3 diagrams, and if you do calculate the correlation coefficient R, which is basically statistics for how tightly these data are distributed in being aligned, you'll find that the correlation for all these three is going to be very close to zero, although they do have a pattern because R here emphasizes on linear association. Now we return to this scatter plot for cigarettes for US. What kind of trend line do you think this scatter plot is? Is it linear, as in like this? Or is it a logarithmic function like this? You may want to write down your answer in your notebook and share this with your teachers and peers. Thank you very much for watching. I hope you enjoy it.